So essentially what I'd like to do today is I'd like to kind of just review what we've done. So we're going to do something, I can't remember if we've done this in here. That's a typo, but if we've done anything on Socrative in here yet, but we'll start by doing just some review questions, and then we'll do some practice problems, and that will be our day today. So if you would, so the website, I'm going to put the website you need to go to in the chat. So it's Socrative.com, and you can either use your phone or you can just open another browser tab and go to Socrative.com. And then when you get there, I'm pulled up here, I'll show you what it looks like. When you get there, you want to go to log in, and then you're going to log in as student. And this room name that you're going to use is ROHRPHYS. Oops. That's the code, and I'll put that in the chat here. So Socrative.com, sign in as student, and then use this code ROHRPHYS. I'm going to give you a moment to get logged in there. And just so that I didn't miss anyone, if I read your name and you're there and I missed you, make sure to let me know. Lee, Aiden, Grant, Audie, Noah, Ivana, Sam, Danny. Those are who I'm missing. None of you are hiding in there anywhere. All right. Looks like I'm missing about 2 to log into Socrative. So let me know if you got any questions getting in there. And then I'll go ahead and put a question there so that you can get started on it. So on your, let me see here. There you go. So on your screen, there should be a question, and I just want you to try to remember what are the 3 laws of motion. So in as much or as little detail as you remember, if you only remember a couple of them, just whatever you remember, what are Newton's 3 laws of motion? And again, even if you remember a lot, not sure what it was, just write down anything that you remember. So Sam and Danny, who are just coming in, I'll put these 2 things in the chat. Oops. So the website you need to go to is Socrative.com. That's all right, Danny. So I don't know if you saw this. The website you need to go to is Socrative.com, and the code is ROHRPHYS. You can either do that on like a separate browser tab, or you can do that on your phone. All right, let's see how we're doing here. Yeah, good. So this here would be what I'm highlighting on my screen here. This is the correct summary, right? Remember, the first law is inertia. The second law is F net equals ma. The third law is interactions. I like this one gives a little bit more detail, right? The first law, when we talk about the law of inertia, what is it? Every object continues in a state of rest or a state of motion unless acted on by a net force. An object's acceleration is proportional to net force, and it's also inversely proportional to mass. And then whenever an object exerts a force on another object, the other object exerts an equal force on the first object. Yeah. So there we go. First law inertia, second law net force, third is the equal opposite. So yeah, so that's a reminder. So first law in summary is the law of inertia. Second law in summary is it's the law about forces, masses, and accelerations. And the third law in summary is the law about interactions. Every action force has an equal and opposite reaction force. Okay. So with that in mind, I'm going to ask a follow-up question. If the net force on a car is 0, which of these correctly explains Danny, so are you on soccerdiv.com? If you are, then there's a button that says login and then say student, and then say login as student. And then that's when you put the code in. So it's login, then student, and then you just type in that ROHRPHYS. One thing this question doesn't ask, but you may remember, there's another word for saying net force is 0. Anybody remember what the other word for saying net force is 0? It's not really a word, I guess it's a phrase. It's called mechanical equilibrium. So saying the net force is 0 is like saying that the object's in mechanical equilibrium. All right, let's see how we did. Okay. C is not the correct answer. I don't know why I said C was the correct answer. It is not. The correct answer should be B. I'll have to fix that in a minute. The correct answer should be B, right? Because the idea is that if there are 2 times that a net force is 0. Net force is 0 when it's at rest or if it's moving at a constant speed. So it may be at rest or it may be moving at a constant speed. So the correct answer should be B. I don't know what I did wrong there. All right. See what we can do with this one. Didn't go. All right. Imagine that there are 2 objects on the floor in front of you, a tennis ball and a bowling ball. Which will be easier to speed up? And which law explains why? So another way of saying that would be, which one is easier to accelerate? Which one has a greater acceleration? So Lee, I'm posting in the chat the information you need to go to this website, socrative.com, then log in as a student and put in this code. ROHRPHYS. Let's see how we did on this one. Good. The tennis ball is going to be easier to accelerate, right? Because the tennis ball has less mass and therefore has more acceleration. The law that tells us about mass and acceleration is the same. All right. We know that the Earth pulls the moon. This is why it travels around us. Which law says that if the Earth pulls the moon must also pull the Earth? Good. This is an interaction, right? If the Earth pulls the moon pulls the Earth. That's what third law is talking about, right? So now we said that the Earth pulls the moon pulls the Earth. My next question is, which force is larger? Does the Earth pull the moon more than the moon pulls the Earth? Does the moon pull the Earth more than the Earth pulls the moon? Or are those forces the same? Good. It has to be the same, right? That's what the third law says. The third law says that every action has an equal and opposite reaction. So if the moon pulls the Earth, sorry, if the Earth pulls the moon pulls the Earth with an equal and opposite force. So it's going to be the same force. I don't remember what question 6 is, so give me a second here. No, all right. So I just want to stick on this for a second then. Why does the moon move more than the Earth? If the forces are the same, why is it that the moon moves more than the Earth? Anyone got an idea? You can feel free to just put it in the chat, or you can open up your mic. Yeah, Max, the idea is the mass, right? The moon has less mass, and so therefore the moon is going to accelerate more. So that's the second law, right? So the poles are the same, but since the masses are different, the accelerations are different. All right, next question. You didn't see that, did you? When you are driving down the interstate and a bug splats on your windshield puts a force on the bug and the bug puts a force on the windshield. Which object exerts a larger force, the bug or the windshield? You would think that the windshield exerts a larger force, but that's not how it goes, right? This is still the third law. If the windshield hits the bug hits the windshield with an equal and opposite force. So the forces are equal. They're equal but opposite. So why is it better to be the bug? Once again, it's better to be the bug because of what? Or no, it's not better to be the bug. It's worse to be the bug because of what? Mass again. Yep. Bug has less mass and therefore bug has more acceleration. Right. I thought that was the next question, but it's not. So the forces are equal when a bug hits the windshield. The force that the bug hits the windshield is the same as the force of the windshield hits the bug. It's just the bug has more acceleration, and its backside sort of accelerates through its face. And that's why it goes flat, right? But it's not because it feels more force, it's because it has more acceleration. All right, last question before we do some practice problems. A hammer puts a downward force on a nail. That's the action force. Which of these is the reaction force? Okay. I want to be clear about, in terms of when they talk about action and reaction with the third law, they always follow the same pattern. Hammer hits nail, nail hits hammer. Hammer pushes nail down, nail pushes hammer up. That's what I mean by action and reaction forces. In everyday language, we can make it seem like the nail reacts by going in the wood, but that's not what we mean by the third law. By the third law, we mean that if hammer puts force on nail down, then nail puts force on hammer up. Now, the results of these two forces are different, right? The result of the downward force is the nail goes down. You want to know what the result of the upward force is? What does the upward force do? Well, think about what has to happen, right? The hammer is going down, right? It's got to stop. It's got to accelerate. How does it accelerate? It has to have an upward force. So the downward force on the nail pushes the nail down, but the upward force on the hammer stops the hammer, right? So that's why you have to have both forces. All right, I got 8 questions here. All right, let me just switch over here. If you got your notebook out, go ahead and get it out. If not, just get out a separate sheet of paper. We're gonna do a few practice problems to finish up. Why can't I get out of this? All right. You can label your notebook for today. You can just label it the day 38 assignment. Again, this is not going to be anything new. I just want to remind ourselves, since it's been nearly a week since we last talked about it. I want to do some practice problems. So here's the first one we're going to do. Consider a skydiver. Before opening her parachute, a 57-kilogram skydiver experiences 457 newtons of air drag. What is the magnitude of her downward acceleration? All right. I'll just say this is 1, part A. So the idea here is, right, we got a 57-kilogram skydiver experiencing 457 newtons of air drag, right? So that'd be FD, it's 457 newtons. And I want to know acceleration. All right. Remember how we do these? The next thing we do is we do our picture, right? Our free body diagram. So go ahead and see if on your paper you can you can do a free body diagram for this case. Remember, you start with free body diagram with a dot, and then you draw any forces that are acting on that dot. And I think in this case, there are two. If anyone knows what one of them is, go ahead and put it in the chat. Gravity, yes. And it kind of told us what the other one was, right? The problem tells us what the other force is. Anyone got it? How about this? Yeah, force of drag, air drag, right? So I'm going to say these two. Now, if I'm going down, right, I'm going to assume that the downward force has to win. So when I draw, remember I draw my net force as a double arrow, and it goes in the direction that's winning. I suppose it's been a while since we've done this, so I'll remind you a couple things real quick, right? Let me, let's see here. Remember, we've got three equations. You might have them handy or you might not, but I'll go ahead and write them up here just in case you need them. Remember, we have F net equals MA. We have FG equals MG. And then we have F net equals plus minus F1 plus minus F2 plus minus dot, dot, dot. And remember, the two that we always use are this one and this one. Okay. So I have these two equations and I'm always going to use F net equals MA. And then remember, this one just means add any force that's going in the same direction as net force and subtract any force that's going against it, right? So my two forces in this case are gravity and drag. Do we think in this case that gravity is going to be positive or negative? Different than we're used to. Anyone got an idea? Is gravity going to be positive or negative in this case? Yes, Danny, it actually is going to be positive, right? Even though it's going down. So I want to make this clear. We're used to saying gravity is negative because it's going down. But in this case, if the net force is going down, gravity is going in the same direction as net force. So gravity is going to be the positive. Drag is the one going against it. So drag is going to be negative. So then what I'm going to do is I'm going to combine these two equations together and say that MA is equal to gravity minus drag. And the one other thing we know is that gravity is equal to mg, right? Force of gravity is equal to mg. So this becomes MA equals mg minus FD. And this is just a plug and chug problem now at this point. So when you've got it, go ahead and check your answer here. I'm getting 1.78 meters per second squared. Any questions? Let's go ahead and do part B here, right? Part B says a few moments later, she reaches terminal velocity, which means she is no longer accelerating and is now falling at a constant speed. What is the air drag force at terminal velocity? Well, here's my question. How does my free body diagram change at terminal velocity? So by the way, you may not have heard this term before. Sorry, I'm going too fast. Terminal velocity just means you keep accelerating as you fall, but there comes a time when there's so much air that you can't fall any faster. That's what we call terminal velocity. But basically, terminal velocity just means no more acceleration. If there's no more acceleration, which direction does which force has to win, drag or gravity? If there's no acceleration. Now, if the drag was winning, you would have an upward acceleration, right? And you'd be slowing down. They have to be the same. Yeah, that's the key, right? If I'm at terminal velocity, if I've got no more acceleration, what that means is that drag is equal to gravity. So in this case, I would know that drag is equal to the force of gravity. So in other words, drag is equal to mg. I got 558.6. Any questions there? I did not do my timing correct on this lesson, so we are closing in on the end of the period. There is a place to upload this, but I want you to skip that. So I'm gonna, as soon as I get off here, I'm gonna close that upload spot. Don't worry about uploading this today because we're gonna have to finish next time because wait a minute. That's not true. I've got to 11:30. You guys thought you got out of something. I thought I only had till 11:20. I had till 11:30. Never mind. We'll keep going. Anybody got any questions about this first one? Can I move this? All right. I'm going to give one for you to try on your own. There's actually two here, but just start on number 2. Neil is stealing a refrigerator from the bank. If the force of friction on the refrigerator is 254 newtons, what force must he apply to have an acceleration of 1.27? So see if you can do number 2. Nobody going to ask the obvious question? That's fine. Usually people ask me why you're stealing a refrigerator from the bank. And my answer is, it's the element of surprise. Nobody's expecting that. While everyone's watching the safe, you just steal the refrigerator. Exactly. Refrigerators aren't cheap either. You can get some good food, or you can get some good money selling the refrigerator. There are 4 forces on this free body diagram. What are they? I agree, Danny. Yes. Anybody else awake out there? Yeah, no, that's right. So we've got gravity, right? Remember, just a reminder, gravity pulls things down. That one's the easiest one. You're always going to have gravity. Normal comes from what, right? This has normal force because it's sitting on a surface. And then we're pushing it forward, and there's friction. And the only other thing I would add on this is I would say, okay, the net force is that way. So force of friction is 254. Acceleration is 1.27. All right. If you haven't yet, go ahead and continue to solve the problem. I think what I'll do is this. I'll give you the answer here in a moment, and then I'll have you ask any questions you have. Second here. That is my answer. I want you to see if you can get that, and if you have questions, let me know. Good. Right, in this case, the net force equation is going to be equal to applied minus friction, right? So that's how we do this. I'm going to give you the last one to work on. So if you're still working on this, again, I'll leave the answer there. You can ask me any questions you've got, and then I'll put number 3 on there so that you can work on number 3 when you're done with number 2. just give you a hint for number 3. That's my free body diagram for number 3. So again, I want you to ask me any questions you got on these. If you're stuck, please feel free to ask me a question. But those are the 2 answers. Is 3 is the last one, Gabe? Yes. Danny, yes. And Kylie, Kylie, we're going to say that FT is positive because it's in the same direction as the net force. So in this case, it's going to be FT minus FG. Did I get everyone's questions? And then if you wouldn't mind, we are at 11:30 now, so I want to let you go. Again, I just want to see where you're at. So if you would just upload where you're at on this, I don't want you to finish for homework or anything. I don't want to bleed into your lunch hour. So just take a picture of whatever you've got and turn it in. And you won't be counted off for anything you've missed. I just want to see how we're doing. We'll have, I'll see you on Wednesday, and then plan to see you in person on Friday. So enjoy the rest of your day. Thanks, Max.